When I was in primary school, I used to have a friend who was constantly copying results from me and cheating during assessments. I was always wondering why he is not trying a little bit harder to study, since he is fairly smart. It turned out that he was dyslexic and needed a specialized approach towards learning, which included an expert tutor, customized material, and more. Without such support, he would probably not have the life he has today, which he is happy with. However, producing resources for dyslexics can be a slow process, and not all the material has been customized. This means that a certain group of people today does not have access to all the beauties which life has to offer, such as great literature pieces with expressive vocabulary. This is an example of where automated text simplification could be handy. There are two main kinds of text simplification: syntactic and lexical. In my project on the topic of text simplification of English language, I have been focusing on the complex terms identification step of lexical simplification. Lexical simplification addresses the issues of complex vocabulary and usually tries to expand them or substitute them for their synonyms to make them more understandable. Complex terms identification, as the name suggests, is the first step of the whole process of lexical simplification, as it determines which terms in complex texts do we actually need to simplify. I try to improve the current approaches of text simplification by identifying the complexity of collocations as well. Looking at collocations is an important task, as the meaning of the whole expression does not have to correlate to the meaning of its constituents. Therefore, despite the fact that single words can be considered simple, the expressions they create can be complex. This is especially true for non-native speakers who might not be used to collocations and idioms. Now we're going to take a look at how the program actually works and looks. On the screen, you can see 5 different folders, which are all included in the final version of the project. The system does not have a user interface and is executed and evaluated only by running Java and PowerShell applications. These are not going to be illustrated here because they take a lot of time and because the audience would be just looking at a process running in a command line. The corpus folder contains news articles which are used as a base for information and results which were produced after the execution of the system. The other folders contain functionalities of the whole system. 2 are for collocation extraction and 2 are for complex terms identification. GetCollocation step produces a list of all the bigrams which were found in a corpus and assigns them a score using the method called mutual information. On the screen you can see a sample list of all the bigrams with assigned scores. Lower the score, less likely it is a collocation. That is why you see some nonsense results or nonsense bigrams, such as many new, way people, which will definitely not be collocations. On the other end of the spectrum though, you can see names like Ben Carson and other people who might appear in some news articles, and it is likely that they would be addressed by their full name, and that is why they're considered collocation, or 2 words which occur together a lot. On this end you can also see some pretty good results in terms of what might be a collocation, like dual citizenship and wedge heels. The ranking of the potential collocations is then used for annotation of collocations in the base corpus, which is then used for complex terms identification of single terms and collocations. On the screen, we can see the differences between the original corpus and the corpus which has annotated collocations. The first sentence says, "The young scientists in this basement laboratory are all gathered around a smartphone." On the right-hand side, in the annotated version, we can see basement laboratory and computer science tagged as collocations. These are pretty satisfying results. The third step now goes through the annotated corpus to produce a list of all the terms and collocations and rank them according to their complexity. On the screen now, you can see a sample of complexities rankings. On the right hand side you have words, and later you will see even bigrams or collocations which were annotated in the second step. in the corpus, and on the left-hand side their scores. The scores were calculated using a method called TF-IDF, term frequency inverse document frequency. The statistical approach says that when a word gets a 0, it is very far from being complex. It is actually definitely not complex. You can see on the right-hand side of these zeros that these words actually are probably among the top 1,000 most common words in the English language. However, once we get away from the 0, higher the score, less likely the term is actually complex, and lower and closer to 0 the score is, more likely is the term going to be complex. Now if we look through the list, at the bottom where the scores are higher, we can see terms which do not look complex at all. Cuba, school, kid, Syria, student. These are words and terms which appear in our daily lives now, especially in 21st century. When we go to the lower scores, we can see more and more collocations, which is because bigrams do occur less frequently than single words in a pattern. Also, we can start seeing words which we do not see in every single article we read today, because at the bottom spectrum we saw words like Syria and Cuba, because the news articles from 2016 were pretty much related to those topics, especially in the US. But at the top we can see words which might not appear in every single news article, like for example bamboo or powdery. The last step serves only one purpose, which is annotating complex terms and collocations in any input text. In the Notepad++, an example of a result is opened, and we can see Google Maps annotated as a collocation because they appear a lot together, and for example, motion sensor being annotated as a collocation and being complex at the same time. However, because of a small corpus or because of inappropriate data, we can have some issues with words like are, which have been annotated complex here. Using a bigger corpus could help prevent this. Results for both complex terms identification and collocation extraction were positive and can be used as a basis for future investigation of text simplification. However, there were some issues which have to be addressed. This was a very interesting project, and I hope to be working in natural language processing field in the future. I would like to thank Mr. John McNaught, who has been supervising me, and Matthew Shardlow, who has been helping me with every single step. Thank you for your attention, and look at the link if you would like to play with the project.